right, good morning. Looks like we are ready to learn about solving right triangles with inverse trig ratios. So let's get to it. So let's just briefly talk about our core concept here about inverse trig ratios. An inverse is something that undoes an operation. So for example, the inverse of addition is subtraction. The inverse of multiplication is division. And the inverse of squaring something would be taking the square root of something. These operations undo each other. So in what we've done in the past, if I had the sine of an angle, like the sine of 29 degrees, I was able to calculate that and get 0.4848 ... But now, what if I asked you instead, the sine of angle A is actually 0.6814. Can you figure out what the measure of the angle is? So in this problem, I gave you the angle and asked you to calculate the sine of it, and you got the ratio or the decimal. In this case, now I'm giving you the ratio or the decimal, and I'm asking you to work backwards to figure out the measure of angle A. That's where the inverse trig ratios are going to come into play. So let's start with tangent. The inverse tangent. If you know the tangent of angle A is x, this would be the decimal like here, okay? Then what we could say is the tangent inverse, that's what the -1, that's an exponent, represents. So the tangent inverse of x is equal to the measure of angle A. All right, let's try it for sine. If the sine of A is equal to x, then the sine inverse of x is equal to the measure of angle A. And cosine, ooh, that one says cosine. That's a typo. This should be cosine. Sorry. Inverse cosine. If the cosine of A is equal to x, then the cosine inverse of x is equal to the measure of angle A. So make sure you have all of this written down on your notes, and then we're going to go take a look at how we can use our calculator to figure these things out. Let's do it. All right, so we're going to use a calculator to approximate the measures of angles A, B, and C to the nearest tenth of a degree. So let's start with the tangent A is equal to 1.321. So this right here is the ratio. We need to figure out what angle measure, when we took the tangent of it, would give us this decimal. So this is where using the tangent inverse is going to be helpful. And remember that whatever you do to one side of an equation, you do to the other side of the equation. Just like in algebra, if you subtract 2 from the left side, you also subtract 2 from the right side. Or if you divide by 3 on one side, you divide by 3 on the other. Well, in this case, I'm going to do the tangent inverse on the left side and the tangent inverse on the right side. And now tangent inverse and tangent, these things are going to cancel each other out, and notice that you're just left with angle A. So the measure of angle A is equal to the tangent inverse of 1.321. This is where we're going to go to technology to help us solve it. So if you have a scientific calculator, whether it's this one or a different version of it, you're going to find this second function. Some calculators say shift, but you're going to need to click on that and then find the tangent button, and you'll see written above tangent in whatever color they're using, it'll say tangent with the -1. So you're going to have to type in second function and then hit that button and then type in 1.321 and hit enter, and you should get your answer. Now, if you don't have technology, if you don't have a scientific calculator to figure that out, and you're using a table instead, what you're going to have to do is go find the tangent column. And I know there's 2 tangent columns, but you have to look at the numbers. So we're trying to find 1.321 in our tangent column. It's not in the first one, so you go over here, oh, here's the ones. And we go here and we say 1.327, that's pretty darn close. It's not going to be exact, folks. I'm not going to teach you interpolation. I'm not going to teach you how to calculate it exactly. If you're using a table, just do the best you can. You're going to scroll over and see which angle that matches up with. So it's about 53 degrees. Okay. So in fact, if you did this on the calculator, it comes out to be 52.9 degrees. Now I'm not going to show all that work every single time. We have to calculate the inverse trig ratio. But this is what you can write down if you need to. Some of you can just do it in your head on your calculator and figure it out. So let's try it out. The sine of B is equal to 0.8243. And if I do the sine inverse of 0.8243, I'll get the measure of angle B, which comes out to be 55.5 degrees. Now in part C, or I guess for angle C, cosine C is 26/38. This is the ratio, but it's not in decimal form yet. If you have a fraction, what you're going to do is you're first going to calculate that as a decimal. And now we turn it into this problem where we do the cosine inverse. So the measure of angle C will be the cosine inverse of 0.6842. And that comes out to be about 46.8 degrees. So if your calculator is different than the one that I showed, you might have to type in the number and then shift or second function, tangent inverse, sine inverse, cosine inverse, or sometimes you hit the shift first and the tangent key and then the number. You'll have to figure out how your calculator works. And right now I'm going to pause and I want you to calculate a specific question that I'm going to ask to the side just to see if you guys can do this. All right, give it a shot. All right, so moving on. Solving a right triangle. This is where you're going to find all unknown side lengths and angle measures. There are 3 sides and 3 angles in a triangle. When they give you a problem, they're going to give you 3 of those things. You will need to find the other 3. Okay, so here's our example. It's asking us to solve this right triangle, round all answers to the nearest tenth. So it's a right triangle, it has to be a right triangle. That's one of the angles they've given you. And they've given you these 2 sides. We need to find C, which is side AB, and then we'll need to find angle A and angle B. So what I want you guys to do right now is figure out what C is. What is the length of that 3rd side? All right, hopefully you didn't say 3, because this is not a 3, 4, 5 triangle. It's only a 3, 4, 5 triangle if that 5 had been the hypotenuse. So instead, we are just going to use Pythagorean theorem. We work through it, and we get approximately 6.4. Okay, now that we know that, we need to figure out one of these 2 angles. I'm going to solve for angle A first. You could solve for angle B first, that's fine. I just chose A. So when you look at your triangle and you know that you're looking for angle A, you have to decide which trig ratio are you going to use. And it's all based off of what sides you know. So it looks like I'm given the opposite side to angle A, and I'm given the adjacent side to angle A. So because I have the opposite leg and the adjacent leg, I'm going to use tangent. And so I can say that the tangent of angle A is equal to 4/5, opposite over adjacent. Now this turns into a problem like we just did on that last slide. Figure out what 4/5 is as a decimal, do the tangent inverse of it, and you get about 38.7 degrees. All right, so now that we know angle A is 38.7 degrees, what do you think angle B is? Okay, so there's a couple ways to figure that out. You could have done a tangent of B to equal 5 over 4 and then done the tangent inverse of that. Or if you're clever and you realize in a right triangle these two acute angles are complementary, you just have to do 90 minus 38.7 and you get 51.3 degrees. All right, there you go. Good luck, folks. Talk to you later.